Hello everyone, Mrs. Belo here. In this video I'm going to be going over the last type of problem that combines everything we've talked about so far in the moles notes and in terms of mole conversions. So up until this point we have talked about how to calculate molar mass using our periodic table. Again, those numbers on the front of the periodic table, those decimal numbers, that is also the average atomic weight of all of those isotopes. However, it is also the molar mass, okay? And what that means is that number tells you how many grams you have per mole of that particular substance. We started with converting between moles and grams using molar mass, okay? So again, once you find molar mass using your periodic table, again, instead of writing it like grams per mole, like that unit, you can also write it like this. And that is something that you can plug into a picket fence. And this can go for between converting moles into grams, like we have here, or converting grams into moles, okay? Next, we used Avogadro's number, which is on the back of your periodic table. And that says that 1 mole is equal to 6.022 times 10 to the 23rd atoms or molecules. So again, that's an equality that we can use to plug into our picket fence. Again, with these, it's important to keep in mind that we're using the scientific notation on the calculator. So 6.022, and then again, you're going to be using that E, okay, to represent the times 10, okay? So again, use that method in your calculator when entering numbers, large numbers that are in scientific notation. So for these problems, we converted moles into atoms or molecules. Again, it's atoms or molecules. It just depends on the substance you're talking about in the problem. For example, this problem right here, it was just talking about gold, so that's why we talked about atoms. This problem here was talking about water, which is a molecule. And then these types of problems, we converted atoms or molecules into moles, again, using Avogadro's number, which is on the back of your periodic table. So now we're going to combine those two skills in these last two problems here. So again, one thing you want to ask yourself is if you ever see grams in a problem, you're going to have to find molar mass. And if you ever see atoms or molecules in a problem, you're going to have to use Avogadro's number. Previously, we were only using one of these. Now in these problems, we're going to be using both. So the first thing I'm going to find is the molar mass of N2O. So on my periodic table, nitrogen is 14.007. And there's 2 of them, so I have to multiply this number by 2. And then I'm going to add, there's only 1 oxygen. So 14.007 times 2 plus the oxygen, which again, you can say that is 16. So 44.014. Again, this is grams per mole, or we can say this many grams is equal to 1 mole. So now I have my 2 equalities, my 2 things that I'm going to be plugging in to this picket fence. So again, I'm going to start my picket fence with whatever was provided to me. In this case, it is 60 grams that we're starting with, and we're trying to convert that into molecules. So again, if you have grams here in the top, grams is going to go in the bottom. According to this, we have 44.014 grams. That's where I'm getting that number from. And then the thing that goes above it is whatever it's equal to, which in this case is 1 mole. So all I've done so far is convert grams into moles. However, I need my final answer in molecules. So I do have to keep going in my picket fence. So again, the unit that's here, we're going to write the same unit in the bottom here. And now I've already used this one here, so I'm not going to use that one again. Now I'm going to use this equality. And again, it is still 1 mole. Okay, I'm getting that from here. And then above it, I'm going to write what it is equal to. 6.022 times 10 to the 23rd molecules. Moles will cancel, and I am only left with molecules, which is what I wanted my answer in. So this is a multi-step picket fence. So now I have to multiply everything. I have to multiply everything in the top. So 60 times 1 times 6.022. Again, the E, you're going to hit the second button. Okay, you can see that little shift. And then the E, mine is 2 blue E's right here. It's right above the 7. It's a comma. And then 23. The E is the times 10. And then the 23 is the exponent. Enter. And then I have to divide by what I have in the bottom, which is 44.014 times 1. So I'm going to get 8.21. We're going to go 3 significant figures. And then note it says E23 in the calculator. So you can write your answer like this. Molecules are the final units, or you could also write your answer like this. Either way would be acceptable. So again, I'm still using my picket fence skill to plug these things into the picket fence so that I'm only left with the unit I want my answer in. So now we're going to, instead of start with grams, now let's do a problem where we're starting with atoms. So again, it says how many grams. So automatically I should think, okay, grams, I should think molar mass. Okay, and this time it's just talking about iron. So it's just talking about an individual element. So on the periodic table, that's 55.845. So I didn't have to do any math this time because this is just one individual element. It's not a compound. And again, this is grams per mole, or we can say that many grams equals 1 mole. Again, I also see atoms in the problem. So I should know, okay, I have to use Avogadro's number. And again, it's atoms this time, not molecules, because we're talking about just one type of element. We're not talking about a molecule or a compound. So now I'm going to start my picket fence with what was provided to me. So 3.022 times 10 to the 24th atoms. That's what I'm going to start my picket fence with. Okay, again, picket fence 101. If I have atoms here, I have to write atoms in the bottom here. How many atoms? Well, my only equality that has atoms is this one right here. So 6.022 times 10 to the 23rd. And then again, if I put that in the bottom, whatever goes above it, it has to be equal to. So that is equal to 1 mole. Atoms cancel. Right now I am in moles, but that's not what I want my answer in. I want it in grams. So I have to keep going. I've used this equality. Again, if moles is here, moles has to go here. According to my other equality, that is 1 mole. So 1 mole goes here. And then again, whatever that is equal to goes above it, 55.845 grams. Moles cancel. And now I am just left with grams, which is what I wanted my answer in. So now I have to multiply everything in the top. So 3.022. And again, we're going to use that E, 24. And again, when you enter it like this, oh my God, why did it pause? Okay, so now in my picket fence, I have atoms will cancel, moles will cancel. I'm just left with grams, and that's what I wanted my answer in. So now I have to multiply everything together in the top. So 3.022, it's times 10 to the 24th. So again, the E is the times 10, 24 is the exponent. Again, the 24, that is the exponent, and this is also being treated as one number. So I can go ahead and multiply that by everything in the top, so 55.845, enter. And then I have to divide it by what's in the bottom. In this case, I have 6.022 E 23, that's Avogadro's number. So 280 grams if I'm doing 3 significant